Assalamualaikum warahmatullahi wabarakatuh, and good morning to our lecturer Nik Syahidah Afifi binti Muhammad Taujuddin. I am Syamira binti NURWASITA, matrix AE 109, from group 10 to present our computer architecture and organisation project report. So my other group member is FAHMI Danial HAIQAL bin FAZLIN HAKIMIE, matrix AE 1006, and Dayana binti Muhammad Yusri, matrix AE 111. So I will start our presentation with introduction. In computer architecture and organization, execution refers to the process through which a physical or virtual computer executes computer programs instruction. Run and running are used virtually interchangeably. For instance, you run the software each time your web browser is open. Double click the executable file or the shortcut icon pointing to the executable file on the Windows to start the program. When executed, a command program or script that is executes a number of instructions that instruct the computer how to function. This instruction determines what the computer performs. As an illustration, one software will instruct the computer to create a circle, while another might instruct a computer to draw square. Therefore, our group project objective is to conduct an illustration and simulation on pipeline concept and branch delay by using computer architecture simulator, which is WebRISC-V. Next, my teammate will continue. Thank you.
Assalamualaikum and hi doctor, my name is FAHMI Danial HAIQAL bin HAKIMIE. My matric number is AE190006. In this part, I will present the simulation on WebWIS 5-stage pipeline system. So this is the code that we use to show the concept that we learned, which is the hazard, branch delay and the pipeline system. So here we assign S0 as equal to 2 to do the substation, and we also use conditional branch, which is the BEQ, so that we can meet the condition to perform the substation. And next is we use the jump and link to end our program, and we use add immediate value to assign number 2, 1, 23 and 1. So let's see our simulation. So this is our execution table for our simulation. So here I will show the stall that happened and the branch delay, which is the taken or not taken. So this is the stall that happened on the clock cycle number 6 and the stall that happened on the clock cycle number 9 when we use the BEQ instruction. So next, so here for the branch not taken, it happened at this line because we assign 2 to save into the S0 and we assign 1 into the temporary register T0. So when the 2 is not equal to 1, it will not meet the condition and not perform the calculation. Instead, it will not perform the addition calculation because here we can see that the addition process is when when we use safe register 1, so the 1 will equal to 1, so the addition will perform. But in this code we use 2, so what happened when we use two here is for the branch taken, it happened at this line. So at this line, the S0 is equal to T1 because we assign 2 as a S0 and we assign 2 as a T1. So 2 is equal to 2. So it will perform the subtraction. So in this line, this label will jump to next label, which is this one. So it will perform the subtraction. So S1 here is 1 and the S2 is 23. So when 1 minus 23, we got negative 22. And it will save at the save register 3. So here is the result that we got at save register 3. So we got the expected result and the correct result because of we have in this pipeline system, we have stallback by using this module hazard detection unit. It can handle the stall, can handle the hazard. We will get the correct result. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Dayana Binti Mama Yusri. My metric number is AE190111. So now I will explain for my part, which is discussion. So based on our result after we run our program by using Fabrics V Simulator, we know that to load the value into the base register in this assembly code, we utilize the operators at one, RD, RS1, and IMM. The at I, RD, RS1, and IMM instructions both perform identical functions, but the LI, RD, IMM instruction differs in that it inserts the immediate value as a source into the destination. The following instruction is a conditional branch which controls the jump that is employed if the target address satisfies the condition. This is because the instruction sets the return adder SS to 0 as we use the commands at RD, RS1, RS2 for adding 2 operands and sub RD, RS1, RS2 for subtracting 2 operands to execute the computation. In order to fully understand what is occurring within the microprocessor, we can quickly demonstrate how danger detection, branch delay, and the pipeline idle work by employing all of these instructions. By examining the execution table and viewing the steps that took place during the process, we can simply trace the pipeline system while using the simulator, which we already explained at the simulation part. There are two ways that Fabrics V assembly code can be executed, which is all at once or piecemeal. By executing each instruction in a single step and looking at the value of the registers and the contents of the data memory in the left panel, the user may trace the flow of instructions through each stage of the pipeline. The internal state of the architectural components is also shown on the pipeline schematic main page for students to examine. So that's all for discussion. Next, I'll pass to my friends. Thank you.
So I will continue from the conclusion. Finally, we can conclude that the three types of mnemonic instruction are RV641, RV64M, and pseudo, and each has a particular function, which is RV641 may be used to load and save data with the 64-bit instruction that are utilized for bit manipulation and arithmetic operation. This RV641 can carry out quick commands and is categorized as register to register. While division and multiplication are handled by the RV64M. Moreover, we execute this application on the web RISC V simulator to simulate the general function of this simulator may be used to demonstrate the idea of computer architecture and organization. Moreover, the subsequent instruction can make use of the instant value that we assign. The following instruction is a conditional branch which to control jump that is employed if the target address satisfied the condition. Additionally, we also use the unconditional jump for unconditional instruction, and the label is to control jump. That's all from us. Thank you.